This is a test setup I put together for testing TI ignition modules. It's not an optimum one. I don't have a TI harness. I'm going to be getting one soon, but I had to put something together to try to do some testing of these old modules. I promised you guys some waveforms, and guess what? We got some. Anyway, I've got two old Delco modules here, and I really don't like using them in today's restorations because they're old, 40, 50, even older than that, 50 years old. So I like using the upgraded, newer modules. Anyway, I got a coil hooked up to a spark plug. I got a TI distributor I borrowed from a buddy of mine. Got that wired up the way it's basically wired up in a car. I've got a ballast resistor on the coil just to keep the voltages a little lower. That reduces the spark a little bit, but just to test the modules, I want to be able to see the spark in some waveforms. Anyway, the waveforms, this probe right here, and here's the oscilloscope right there. There's a battery source, and I got it fused too. I got a big fuse there. I've got a 2-channel oscilloscope. The first channel, which will be the top waveform, is this. This is the trigger transistor. Basically from the TI, comes through what I have is a yellow wire. It comes into the module, comes into the gray wire. Gray wire is the trigger wire coming from the distributor pickup coil, and then tapped on what I believe to be the output of the trigger transistor. The second channel on the scope, this probe here, is the black wire, which equates to the output going to the coil. And so the pulse comes from the TI distributor, which is basically a generator. Power comes in on the white lead, and when you turn the distributor, when the engine turns it, it generates a pulse which comes out the green wire. Normally it's white with a green tracer on original. This is a over-the-counter replacement. And we go through what my yellow wire is, up and in to the gray position, which is the trigger. So a very small voltage coming off the distributor generator, we'll call it, triggers the module. These power, that little trigger transistor, here's another one here. That little trigger transistor and all the components supply the proper voltage to these power transistors, and those are what generate the high current, which comes out on the black wire, this terminal. It's that terminal there, which goes off to the coil to generate the spark. I got all my grounds connected to the case, ground going to the battery, ground for the spark plug, so it's kind of like an engine. Anyway, enough boring discussion. Let me just connect up the battery, and this is my rotating assembly tool. Hook up battery. I got a separate lead going to my digital voltmeter. I got about 12.5 volts, I think. 12.33. And I'm gonna shut the light here so we can see some spark action. And hopefully you can see it. I'm going to just turn the distributor. Not very fast, you don't need it very fast. And you should be able to see some sparks going on. So this module is good. And I tested the other module, that one's also good. And let me put the camera in my stand here. And you can see the waveforms happening. Now, the top waveform, okay, this is DC voltage. This is 0 volts and that's 0 volts. This line is going to be pulsing, and that is the trigger transistor. This line is going to be pulsing, and that's the output of the amplifier unit TI module going to the coil. So as I rotate, the upper waveform is going to go positive. You can see it. I need another pointer. Okay, the top waveform is the trigger transistor coming from the distributor, pickup coil, generator. And when that rises, that triggers the amplifier, power amplifiers, power transistors rather, in the TI module to pulse negative, effectively shutting off power to the coil. So the coil is positive, then it goes negative, then it goes positive. And if I spread my time base out here, it's going to be tricky to see, but you'll see multiples. The faster I go, I'm going to go fast. It is slow. I'm going to go faster. The faster I go, the more pulses you get. And that's, I'm slowing down, and that's basically how it works when you step on the gas. Let me bring this back out. So trigger from the distributor says okay amplifier, trigger to the ignition coil, it triggers it off and then on again. Basically like a points distributor. And what you see in here also, I have the trigger set to trigger on the positive pulse of the upper waveform. Where'd you go? Problem with my trigger here. There it is. Let me spread this out. What you see with those squiggly lines here, that's called overshoot. That's just kind of normal electronics. This is not super high-speed digital electronics for the computer industry. This is for running an engine. So they're not the cleanest waveforms, but there it goes. Turns on. I should say off. 12 volts. That's 12 volts. 12 volts to 0 volts. And then back up to 12 volts.